Hello, everyone. Sorry, hi, welcome to Karmada community meeting. And today is July 9th, 2024. And the meeting is recorded and will be the video will be uploaded to YouTube. So today we have three agendas, and Joe, uh, Joe, how about get started?
Yeah, sure.
Yeah, I think it might be your first time to join the meeting, right?
Yes, this is my
Yeah,
first meeting.
yeah. Nice to meet you.
Yeah, nice to meet you as well.
Are you going to share your screen?
To look at the proposal.
Yeah.
Okay. I can share. I thought you were going to share, but I can share it.
Sorry.
Let me, 1 second. Let me bring it up. Yeah.
Yeah. Cool. So, how about you give a brief introduction for
Okay.
your proposal for
Okay.
get the
Yeah. So at Bloomberg, I work on the managed compute team. Currently, we're building a managed Karmada platform, which obviously is leveraging Karmada.
Mm.
And to manage um, control the life cycle of control plane tenancies, we want to use the Karmada operator. Um, and as I was doing a proof of concept for how we can actually leverage the Karmada operator to
Mhm.
manage the life cycle of Karmada control plane instances, I noticed some limitations, which this proposal aims to address. It's a couple
Mhm.
of them. The first one is that as a prerequisite for provisioning a new Karmada instance, the Karmada operator needs to ensure that required CRDs are downloaded
Mhm.
from some remote server. By default, it will attempt to download the CRDs from a release artifact on GitHub. In an internal corporate environment like Bloomberg, um, where we have network policies that by default will restrict accessing resources on the internet, right? That's a problem. Um, um, so that's one of the limitations. Um, the the other limitation is that by default, the Karmada operator will assume that whichever the version of the control plane instance that you would like to provision has the same will have the same version as the Karmada operators release version, which may not always be true because when provisioning a new control plane instance, right? You have the ability to specify exactly which Kubernetes versions you want for the standard Kubernetes components or which versions you want for the Karmada components. So that introduces the risk of version drift, where you might have the wrong CRDs installed for that control plane component. And if that happens, then that might be like an insidious problem to trace. So that's the motive for this proposal, right? And then here I outline a solution for how we can fix it, right? So for the first one, given that we may want to actually download the CRDs from some
mm,
server that is accessible from within our corporate environment, right? We would have a new field under Karmada spec. Uh, this is optional, so if it is not set, then the default behavior, which I think is sensible, would be what is executed, where Karmada would just, well, where the operator would just download from the release artifact on GitHub, right? But if that's not the desired behavior, then this field can be set so that we download from a server that we know is accessible from within the network. And for this, you made some comments which I think are sensible. So today, Karmada operator will download from some HTTP server, um, but it's well, your comment is, well, how can we extend it so that not only can the resources be downloaded from some HTTP server, but also like from some FTP server, right? This URL is a
mhm,
generic URL. So today, downloading from downloading an HTTP resource is supported, right? But I think down the line, if we would like to support downloading using different protocols like FTP,
mhm,
then that would not be a problem, given that the URL and the URL today is just HTTP, but down the line, if we want to download from, say, FTP servers, then we can just, in the code, we can just parse the scheme of the or protocol of the URL, right? Decide if it's HTTP or FTP,
mhm,
and based on that, decide which client we want to use to download the resource.
mm,
Um, so that's the proposal for addressing the first limitation. Um, and this also will actually take care of the second limitation, right? If is if the version of the Karmada control plane being provisioned um, is of a version that is not the same as the operator's release version, right? Then we can explicitly specify where to download the CRDs so that the version of CRDs installed would match the version of the control plane instance that we want to provision. Um, and also, so the operator maintains a cache on the file system so that previously downloaded CRDs can be retrieved from the local file system as opposed to having to download them again from a remote server. So as part of this proposal, um, I propose that we also extend this caching strategy so that multiple versions of the CRDs can be cached on the file system. Right. Today, the operator, given that it would always assume that the version of the Karmada instances it is managing is of the same version as its release
mhm,
version. But moving forward, given that it can be managing Karmada instances of like varying versions, right? On the local file system, there will be a cache entry for each of the CRD versions. Uh, so it's very simple. For each remote URL, which would point to some CRD tarball, we would just hash that URL so that we can cache it in the local file system. You also
mm,
made a comment um, regarding that, which I think is also very sensible, right? Like, so when to spin up containers, you need some image, right? And you have to get those from some OCI registry. And with
Mhm.
image pooling, you can have pull policies like always, or if not present. And you suggested
Mhm.
that we do something similar for downloading the CRDs. I think that's very sensible, and we can actually implement that by just adding a new field here, right? Something like CRD pull policy or CRD download policy. And
Yes.
possible options would be like always or if not present, right?
Mhm.
And this would behave very similar to how images are pulled from registries, right? So I
Mm.
think we can also just add a new field to support that.
Yeah.
Yeah. And there's one more comment, the one regarding how we would actually, so when Karmada is for Karmada instances where the CRD remote URL is not explicitly specified, you suggested that as part of reconciliation, we would just get the default remote URL and set it. This might
Mm.
be tricky for newly created instances. Yeah, it's straightforward. We know for a fact that if not explicitly set, we will just get whatever the default is. But for instances that already exist, it may not be as straightforward, right? So if we all say we already are managing a Karmada instance and its remote URL was not explicitly set, so at that point in time, we would use whatever version of the operator at that time to download the CRDs. But if we upgrade the operator to some newer version, then and then at that after that point in time, we say make an update to the existing Karmada instance. Then
Mm.
as part of reconciliation, if we set that, it would be set to the wrong URL. So I think we should not do that because it's tricky and yeah. So in that scenario, I'm not sure exactly how we guarantee that we actually set it to the right URL. Yeah.
Yeah. Yeah. I'm thinking the default value might be set when the if the field not set by user, but after it had been initialized, so the field will not change even in case of a operator upgrade. So I think if this I mean site with a default value would make the controller easier to reconcile the Kamada object. No, so uh,
For newly created projects, after we do have this feature, it's straightforward. Yeah. But in the scenario where we're managing instances that existed before we have these new features in the operator, I don't know how we can guarantee that as part of reconciliation, we would actually set the right URL for those existing instances. We would not know exactly what that should be.
mhm. Okay, I can take another look, and after you are going to change the CRD remote URL to uh, a struct or something, right? You just mentioned the CRD download policy, right?
Yeah. So I think we can do something similar
Mm,
to
okay, okay,
what we have for container specs, right? In a container spec,
yeah,
you have the image and the image pool policy. And here we can just have
yeah,
CRD remote URL and CRD download policy or CRD pull policy. I think we can just add a new field.
yes. I mentioned the policy. because I think there might be a scenario that maybe the cache the CRD table in the cache might be a wrong table, you know, so that with a policy gives the user a chance to ignore the cache, you know, right?
Yeah, I think that's um sensible. And I think by
Mm-hmm.
default this can the and I think for this policy the default value can be if not present.
Mm-hmm. Yeah.
But if the user knows that at whatever URL this resource is hosted,
Mm-hmm.
um, that resource might actually change. Right? I have some tarball on a server at some URL, and I can just change it.
Mm,
Um,
okay. So.
so if the user anticipates that that might happen, right, they can say, hey, always just pull whatever is at that location at the time.
Mm-hmm.
Yeah,
Yeah.
yeah, yeah. Okay, so I'll
Yeah.
just add the new field on here. Yeah.
Okay. Okay. I see. Xing Yan on the meeting, right? Do you have any comments? Hello, Xing Yan. What should I feel in the for? Yeah, I just see comments in the chat. Xing Yan, can you speak? Okay, Xin, I don't quite understand your question here. Do you mean you already load the table into the operator container? Okay, I can hear you, Xin. So how about that? You leave your comments in the PR. Okay. Cool. So thank you, Joe, and
Okay. Yeah.
I'm very appreciate your proposal. Basically, I'm excited to see your proposal. I think it's pretty good. So I just want some extension point. So for if another user they might store their the CRD in another uh, for example another FTP server. So we don't need to change the API and just uh, add the implementation. So yeah,
Yeah. So yeah, I think down the line we can support downloading using other protocols like FTP. Like in the
yeah.
code, when downloading the CRDs,
Mm,
the operator will just use an HTTP client. Down the line, if we support other
yeah.
protocols, then
But no.
yeah, down the line, if
Mm-hmm.
we support other
Yeah.
protocols, then
Uh,
it can just parse the scheme to figure out whether or not it needs an HTTP client or FTP client to download them. Yeah.
mhm. Okay. Note that I I didn't ask the FTP protocol should be implemented by this proposal. Just make the room for the extension,
Yeah, yeah.
right?
So what I mean is,
For this proposal, we still can focus on the HTTP.
hmm yeah, yeah,
Yeah.
I agree. But what I meant is, so for some HTTP resource, right, URL will look like this, but for FTP, it'll look something like this, right? So from at the spec level, there's no change we'll have to make, right? Later on, if we want to support this scheme, it'll be in the code where we
Mm,
just implemented. Yeah. Yeah, but
yeah.
I
Okay.
definitely like this idea. Yeah, I think, yeah, I
Yeah.
think
Okay.
down the
Thank
line,
you.
people will probably want to do that. I have one more question. So usually what's the process? Do we address all comments, get this merged in first, and then submit the following PR for the actual code?
Sorry.
What's the process? Do we usually get proposals merged in and then, as a follow-up, submit the PR for the actual code implementation?
Yeah. Um, I think we can. Um, yeah, I think you might need another update for the proposal with the new fields we talked about in this
Mm-hmm.
meeting, and
Mm-hmm.
after that we are on the same page, so we can start to send another PR for the API part,
Mm-hmm.
and
Mm-hmm.
I think we can finish the proposal, or it doesn't matter actually. So you can uh, uh, we can discuss the proposal here, and at the meantime you
Mm-hmm.
still can send another PR for the API. So no strict rules here.
Okay. All right. Thank you very much.
Thank you. So let's move to the next Mihash and Aditya, right?
Yep. I think I'll
Yep.
let Aditya
Yeah,
go ahead first.
I think there is another great proposal. Yeah, thank you.
Yeah, thanks. I'm just going to go pretty high level over the proposal, and I just want to know if there are any other feedback that I need to incorporate before we can start implementation. Um, so I guess to go over the proposal again, um, so our proposal is to add stateful failover support. So in our use case, which is using Flink with Karmada, we want to make sure that um, the state is can be transferred or migrated during the failover process, so that the Flink deployment or the Flink CRD can then continue from the previous state. And as a part of this proposal, we have two things that we wanted to add to the Karmada code base. The first one is including a failover history field. So this would be all of the data that's, if I can find it. Yeah, so failover history. This is going to be all of the metadata that gets migrated when the CRD is going to fail over. So this is metadata related to, you could say, time from where the cluster originally was and from where it's and to where it's failing over to. And this is going to be like a first part in our proposal, just including these three fields and also adding it to the resource binding status. Um, the second part would be actually adding the fields that are required to be failed over. So if I were to give an example, in our use case of Flink, we have a job ID, which is a 32 hexadecimal ID that Flink generates that we need to be failed over, the exact ID that needs to be failed over so that we can resume processing using the latest checkpoint of that job. And that would be, so that particular ID would be persisted in this struct, which is called a persisted during failover struct. So our label in that case would be job ID, and our persisted status item would be the actual ID or the 32 hexadecimal ID. And yeah, so uh, this would basically tell us which directory we need to fetch in order to get the latest checkpoint and resume processing from there. And this is like a part of the second part of our proposal, which would like this part ties into the propagation policy. Um, so the I guess like the final use case is that the user is going to mention what types of fields they want to be persisted over. So again, this is talking about the Flink use case, but we have the job ID, which can be fetched from this particular path in the Flink CRD. And this path is going to then tell us that we need to fetch the value uh, at this particular path, which is that 32 hexadecimal ID. So this would then get stored over here in this struct. So I ran through that a bit, but I think I don't know if you have any other questions or any other concerns. I did see that you added a few comments today. I replied to those, but we can discuss those too if you have any additional questions.
Yeah, I just asked the question on the PR about the field type you can persist here. Do you mean it can just persist the string type?
Yeah, as far as I know, like since we're going to be adding this under the label field in like the resource binding status, we would probably or like I mean it's under the struct actually here, but I think string is the only field that it supports. So I'm not sure if we can add any other field other than string.
Yeah, generally I like the idea that we can persist some field before failover, so the persisted value can be carried to can be carried when a workload being failover to another cluster. So I like the idea. So my question here is yeah, I just said it can only support the string type, right? Yeah. And
Yeah.
another question is that the information will be set to the label as the label value, right?
Yes. Yeah.
So so speaking of the label value, there's a limitation that it cannot be cannot exceed 63 characters, right?
Right. Yes, that is a limitation.
So, mhm. So I'm I want to know if there if it is enough for the Flink checkpoint path.
Yeah, so for our use case, like we are not storing the entire path. We are just storing the job ID. And we
Job
then,
ID, okay.
yeah, so the job ID is 32 like characters long. So that's not
Mm-hmm.
an issue for us.
Mm-hmm.
Yeah, but I guess like for other use cases, like they would have to make sure that their key and value are both under 63 characters long.
Mm-hmm. Mm-hmm. Yeah. Mm-hmm. So, w- what as firstly, I think the proposal is good enough. What I'm thinking is if there is a chance for us uh, to support more field types, for example, for the integer, um, and map or just a slice. So I'm think, oh yeah, I'm I'm trying to to think if there's a way to for us to support more field types. So this gonna be a more general a solution, you know.
Yeah, I think that makes sense.
Mhm.
Yeah, let me think about that. If we can try to find some way to go over that limitation. Um,
Mhm.
but
Okay.
but
So
yeah,
thank you.
I think that's valid feedback.
Mhm. So another thing, actually, I'm thinking how to do that today. So I figure out the challenge for us to fill over history. You know, in the fill over history, there is a destination cluster, right?
Yep.
Yeah. So I'm thinking who, which component will set the destination and how it can get the destination cluster. That might be a challenge or brings another limitation that
Hmm.
in the resource binding clusters field. What if there are more than one cluster there? How can we figure out which class is the destination cluster?
Right. Yeah, I guess it would probably have to happen after scheduling is done.
Yeah.
Yeah, so I guess we didn't think
We
about the implementation yet.
we could
Yeah.
also just keep the origin cluster, and then the destination will simply be the cluster that's already put in the information of the resource binding status. So if you take a look at the resource binding, it'll already show you where the replicas are scheduled. And you can kind of infer that, okay, given the last time it failed over, this is where the cluster that it was originally on, and now it's scheduled on a different cluster. I don't know. The destination cluster itself might be redundant information.
Mm,
Hmm. Yeah, that's an option. You could have like a string of origin clusters, which basically means that the second one would be the destination for the first one.
yes, that's the case. There are only one cluster should be there, right?
Yes. Yep.
Mm-mm. Yeah.
Yeah, since we're assuming that all the replicas will be migrated together, you would only have one origin or one destination cluster.
Mhm. Okay.
Yeah, I think with this proposal, for us, what's explicitly required as like a first step is just marking the resource binding with some sort of flag that tells us that a failover occurred, and that this flag would be set on the resource that's getting scheduled after it's been failed over. And that's like what we need at first. So with this proposal, I think that's the first change we would be working on. And then in terms of like a failover history, that's something that we would work on after. And so we haven't been thinking about that implementation as deeply as with the failover flag.
Mhm.
But yeah, I think the most serious limitation is like you were saying, the 63 character limit. That's something that we'll need to take a look at.
Okay. 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 Yeah. The next proposal, I want to share some progress. I just shared the proposal at our another community meeting, mostly for China guys there. So I also invited some scheduled authors to look into the proposal, and we are so. I think we are waiting for some feedbacks or comments. Um, so yeah, I think I think we can make some progress in the 1 or 2 weeks. So is that okay for you?
Yeah, I think that's okay. I'll leave some open questions. I'll just comment them on the PR itself, and then someone from the community can probably respond there. I think the biggest question with the multiple pod template support is first the estimation portion, because if we decide to set multiple components and each component has a different request requirement, then will we be creating a max replica estimation for each component, or
Mhm.
do we also need to take into account during the max replica estimation, like the actual spread of the replicas? Because I'm assuming for resources with multiple pod templates, those resources should probably be scheduled on the same cluster, meaning that the spread constraints would be on the same cluster. Um, and in that case, with the max replica estimation, we can kind of take that into account. Whereas if both components could technically be divided amongst clusters, if you do a max replica estimation for each component, well, then you could run into situations where there are conflicts, where you might have enough space to schedule the replicas for a single component on a cluster, but that might not have enough space for the other component to be scheduled there. But the max replica estimation won't account for that. So I'm wondering if when it comes to scheduling resources with multiple components, is it something that we can assume that all the components will be scheduled on a single cluster, or is that something that we can't assume?
Yeah, that's what exactly what I'm thinking about. So I think it's totally acceptable for us to assume that the workload with multiple components, they should be scheduled to a single cluster,
Okay.
because for now we don't have such a scenario or use case for the different for the component to be divided to multiple cluster. We don't have
Okay.
such a use case, but apparently it is quite hard to do that.
Yeah.
That be much a challenging thing, you know. So we don't worth for us uh, to work out
Sure.
that complex solution. Right?
Okay. Yeah, that makes, I think, the problem scope a lot neater.
Yes.
Okay. I'll update my proposal with that assumption then, and I'll wait for feedback from the community.
Okay. Thank you.
All right, thanks.
So so now we are moving to the third agenda. Hi, hi. I don't know your name.
Hi, this is Bharat. I'm working in Flipkart. This is one of India's e-commerce company. So I'm working in the Kubernetes as a service platform that we have within our company to offer Kubernetes uh, related functionality to our app developers within our company. So we have uh, compute presence in our private cloud as well as public cloud. And we were experimenting with the multi-cloud federation idea, and we came across Karmada uh, community and the project, which interested us, and we started doing some proof of concepts internally, right? So the use case that we have is primarily we have a private cloud uh, which is self-sufficient in most cases. However, there are time periods during an year. Example, there can be some sales, e-commerce sales that can be there, during which we would scale up all our applications. We internally have an auto scaling solution that does seasonal auto scaling, which would scale up all the services. However, there are a bunch of preemptible batch workloads that can leverage this. When the workloads are scaled up, some of these batch workloads need to be burst into the public cloud where we have a certain limited footprint, right? As part of that, we were testing a scenario where workload will be scheduled in our private cloud, and then when there is no capacity or when the cluster is low in capacity, these workloads will be rescheduled to the public cloud. And then when the capacity is available back in our local the private cloud, it would be rescheduled back to the so that that burstiness, right, comes down, right. So we initially weren't able to do the rebalancing. We weren't aware of this workload rebalancer, right? So we came across that this workload rebalancer as a concept has been introduced in 1.10, and we tried using it. However, I still see that with workload rebalancing, we are still considering the historical context of the scheduling decision, right? For example, the scheduler cluster affinity that is chosen by the scheduler is still sticky in nature, and and the resource binding has that in its status. And every time a workload rebalancing is happening, it's not considering the previous cluster groups in the cluster affinities uh, that have been evaluated sometime before, right? So in that sense, we felt that the workload rebalancing is not doing a fresh rescheduling. So mm, I was discussing with the community. Let me present. Are you able to see my screen?
Yes. Yes.
Yeah. So basically, I don't have a full-blown proposal, but what I feel is that this solution can be implemented on top of the workload rebalancer construct itself, where we can all, enable the user to specify or toggle where he chooses whether whenever a rebalance happens, whether the scheduling decision traverses the entire set of clusters in the propagation policy or resumes from the previous point. So in terms of implementation, it would just be extending the workload rebalancer. So I was just going through the workload rebalancer controller and the scheduler code. I felt we are doing the resuming from the previous point. We are getting the cluster affinity index, and then we are just traversing from that point onwards. So, what do you guys think about this?
Yeah. Firstly, I want to say that when we start the workload rebalancer, actually, I'm thinking the default behavior would be just as you mentioned. It should be a fresh rescheduling, and the flash is the scheduler will look the first affinity group, and then go to the next if the first cannot meet. So I think what you are asking is a very reasonable feature. So I think we can do that. By the way, I noticed that you are asking if we need a fresh proposal. Um, what I'm thinking, if we can just iterate the previous proposal and make an update to that one.
Sure. That makes sense. In fact, when I came across this workload rebalancer, I was assuming that the fresh scheduling would be the default behavior. So what we could do is we could just augment the previous proposal and implement this within the workload
Yeah.
balancer construct itself.
Yes. Yes. Thank you. Charles,
Thank you.
are you any comments from you? Do you have any comments?
I think his avenue can be a default behavior of workload rebalancer, and I think what he said about how to implement it is okay. It's we can do like what he said.
Yes. I think the I didn't think about how to implement it. But a general idea is that when we trigger the rescheduling, we need to set the affinity group index, right? Set to for example, set to 0, so the scheduler can start the first affinity group.
Yes.
Yeah. Okay. Thank you. By the way, are you living in Indian, right?
Right.
Yeah. I think it's gonna be quite late for you, right?
It's not quite late actually. It's just 9:30 p.m.
Mm-hmm. Yeah. Oh, okay. Yeah. Sure. So actually, I'm I'm in the midnight right now. Okay. Thank you.
Thank you, guys.
So Thank you. So I think we have just been over all the agendas. So if no other topics, so I think we see you next time.
Thanks again.
See you. Thank you.
Thanks. Bye.
Okay, see you. Bye. Bye, Wang Yao.